So in this video, I want to talk about when should a number not be a number. And you might be going, well, wait a second. What does that mean? Numbers should always be numbers. Well, that's not always the case. If you remember back when we talked about primitive data types, we talked about how there's an issue with we have a maximum value that we can put on a number. For an integer, that's approximately plus or minus 2 billion. So I want to show you real quick a couple of examples of when we're going to use numbers as numbers and when we're not going to use a number as a number. So the basic rule that we want to think about is I'm going to use a number data type, integer, double, whatever, anytime I'm going to do something numeric with my value. So here's an example of a really simple shopping cart that I built. And I have both price and quantity. So if I've got a shopping cart, I might want to loop through my shopping cart a price and multiply it times a quantity and add that to a running subtotal. You can see that here. So I'm doing things like adding and multiplying. If I need to do things like find an average or the minimum or maximum values, then this makes perfect sense. And if I go and I run this, you'll notice it comes up and it gives me a subtotal based upon the cart that I created. Okay, so in this case, because I'm doing numeric things with my numbers, I'm going to store them as a number. Now, this, of course, is in Python. And so in Python, it's going to do a lot of this for me, but I'm not going to do things like put quotes around it because it's not a string. It is a number. I'm using it as a number. So let's take a look at a phone number. Now, a phone number is not something I'm going to be adding. I'm not going to be subtracting it. I'm not going to be doing any of those types of things. So a phone number, I probably want to use as a string. And there's a second major reason for this. So I have here system.out.println, and in it I pass integer.maxValue. This is the maximum value a number can be. And if I go and run this, you'll see that I get 2,147,483,647. Now you might go, that's a pretty big number, but phone numbers are larger. So here I have integer phone number, and I'm going to say 555-867-5309. And you'll notice that my editor has given me an underline. It actually makes an error here. And if I hover over this, it's going to say, hey, this literal value that you're trying to pass in and you're trying to store as an integer is out of range. It is too big. And so while an integer might be a smaller amount of data, it is too large for us to store as an integer. So I need to think about, well, how am I going to store this? Am I going to store this maybe as a string? That is definitely one thing I could do. And I could come over here and say, okay, I'm going to create a string. And then I need to, of course, put this inside of quotes. And now I have a phone number and a string because it can be anything and of any size. It doesn't matter if I do that. And I can even format it and put dashes in it or maybe parentheses around it or however I want to do that. So I get a lot of flexibility with how I'm going to store a number if I store it as a string, including formatting, etc. I don't have to worry about exceeding the size of my number or having to go to a different one. Now, maybe another option is I could create a user-defined data type of phone number, in which case I'm going to store things like my country code, and I'm going to store things like my area code if I'm in the US, and I can now do prefixes, and so I can start to determine how do I want to set up exchanges and how do I switch between different phone banks. And the way the US phone system is set up, those numbers and those groupings of numbers all mean things, and they were built way back almost 100 years ago. They were implemented to make for mechanical switches to actually be very efficient. And so there's a lot of different things that go into that. We're not going to worry about that at this point, though. We're just saying, okay, here's a phone number. It's too big to be stored as a number. So I either have to come with a user-defined data type or I need to store as a string. And going back to our previous kind of guidelines that we want to follow, since I'm going to take a phone number, I'm not going to do things like add two phone numbers together or find out who's got the average of the phone numbers or anything like that. Now I'm saying, well, maybe this number should not be stored as a number. I'm going to store it as a string. Now, sometimes we're going to run into a little bit of an issue, and I'm going to show you just a real simple example here. In Python, I'm going to create a variable called age, and I'm going to create a value of 123. So this is something that makes sense. It's a little bit old. 123 is old for a person at least, but we're just going to go with this for this example, if you don't mind. And I want to check to see if someone is older than 21. So I'm going to say if age is greater than 21, print older, else print younger or equal to. Okay, so this is very, very simple. You might go, well, I don't see what this is, the matter of this is. And if I run this, you'll notice that it prints older, just like you would expect. 123 is clearly older than 21. But you might go, well, wait a second, I'm not adding ages together and I'm not finding out, some of those type things. And so I'm going to store it as a string instead of a number. Well, first off, we're now taking more space. Strings being an object takes more space to store than an integer. Sometimes that's okay. And we saw that with a phone number. But here it's going to cause another issue. And notice I haven't changed anything other than putting it in quotes, so it's now a string. And if I go and run this, notice that now it says I'm younger or equal to. You might go, wait a second, that doesn't make sense. 123 is still greater than 21. Well, it happens to deal with how we're using the greater than or less than, those equality type of operators. You see, when we look at a string, we evaluate it as a string, not as a number. So when we evaluate these as strings, it looks at the string value of 1, the first character in 123, and then it looks at the 2, the string 2 in that string of 21, the first character. And it says, okay, is 1 greater than 2? No, it's not. And it quits checking. And that's to speed things up a little bit, because if I'm looking at names, and I'm trying to put names of books in order, I look at the Iliad and the Odyssey. I go, Iliad, well, that's I is before O. I don't have to look at anything else. And so because of it, I want to make sure if I'm going to do comparisons, not just adding and subtracting things like that, but if I'm going to do comparisons, I need a way to handle that to make sure that it's accurately measured and worked with. So this is just a real simple example of trying to figure out, okay, should I store something as a number or not as a number? And just because it has the name number in it doesn't mean I'm going to store it as a number, because phone number, as we saw, was too big. Social security numbers, once again, too big. Okay, we're not going to do numeric things with them, and that's going to be true for things like employee numbers and student numbers and a lot of those different types of things. So even though it might have the word number in it, we don't necessarily store as a number. If there's any chance there's going to be a letter, so a lot of times your insurance ID number starts with the first letter of your last name. Why do they call it a number? I don't know. Your driver's license number has the same type of situation in many states. So therefore, anytime there's going to be something that's not a number stored in it, we definitely have to store as a string. Then we're going to look and say, okay, am I going to do mathematical things? Adding, subtracting, multiplying. If I'm not going to be doing those, maybe a string, maybe a number. Okay, if I'm not going to be doing it, I'm probably leaning towards not a string, but I need to also do my final check, which is going to be my conditions. And is it okay to conditionally check it as a number or as a string? If I'm still going to not be doing any mathematical things, I'm not going to be comparing it, or comparison as a string is okay, I'll store as a string. But if I am going to be doing mathematical, whether it's addition, subtraction, multiplication, etc., whether it's finding a minimum or maximum value, doing numerical comparisons, then I need to store as a number. And so those are things I have to kind of keep in mind when I'm deciding what type of data should I use, a number or a string or possibly a user-defined data type.